Hello and welcome to my presentation on a possible sustainable energy profile for Tennessee in the year 2032. My name is Rachel Brees, and I want to thank you for watching my presentation. Please excuse my voice. During the duration of this video, I'm feeling a bit under the weather. That being said, let's get started. We're going to start out with a general overview of Tennessee's current energy profile. From the EIA's website, you can see Tennessee's major energy sources are hydroelectric, nuclear, and coal. From the pie chart on the right, you can also see their largest consumption sectors are transportation and industrial. As for total energy per capita, consumption is 329 million BTU, which is 19th out of all the 50 states, and expenditures is $3,621 per capita, which is 25th out of all the states. From my own calculations, Tennessee has total CO2 emissions of 44,203,972.08 metric tons. Again, looking through the EIA's website, I drew my own evaluation of Tennessee and its inclusion and reliance on traditional and renewable energy. Tennessee's biggest energy producing sources are nuclear electric power, other renewables like hydropower, and coal/biofuels. However, the biggest energy sources consumed are coal, motor gasoline, natural gas, and nuclear electric power. The Tennessee Valley Authority, or TVA, provides more than 90% of Tennessee's electricity, as well as to 6 other states, as you can see in the picture on your right. In Tennessee, TVA has 2 nuclear power plants, 19 operable dams, 6 coal-fired plants, and 7 natural gas-fired generating plants. Tennessee produces very small amounts of natural gas and crude oil, but imports tons for its energy needs. As for renewable energy, Tennessee does not have a renewable profile standard, but the state has hydroelectric, biomass, solar, and wind energy potential, and was an early leader among southeastern states in developing renewable energy. Hydroelectricity is the largest share of renewable energy in Tennessee. Additionally, solar photovoltaic facilities provide about 2% of Tennessee's renewable generation in 2016. Setting records, Tennessee hosts the Southeast first wind farm that produces 29 megawatts. Lastly, biomass, primarily from wood and wood waste, contributes the second largest share of renewable generation. Overall, my evaluation stands that Tennessee has a plethora of ways to renewably produce energy, yet they still import tons of coal and natural gas each year to meet their standards. I have divided the resource evaluation in Tennessee into 2 categories, production and consumption. As for production, Tennessee only has bituminous coal and has some untapped lignite coal reserves. Also, Tennessee has little natural gas reserves and produces less than 0.02% of the nation's natural gas. Less than 0.01% of the nation's crude oil output is produced in Tennessee today, but the state has no significant proved reserves. Tennessee helped usher in the nuclear age with the nation's first nuclear fuel enrichment plant, built at the Oak Ridge National Laboratory as part of the World War II Manhattan Project, and is the most produced energy source in the state. As for renewables, biofuel and hydroelectricity are the major producers. With 109 hydroelectric turbines operating, Tennessee is one of the top 3 hydroelectric power producers east of the Rocky Mountains. As for the converse side, consumption, Tennessee consumes mostly what it does not have. Tennessee consumes 20 times the amount of coal it produces. Tennessee's natural gas needs are met by almost a dozen interstate pipelines that supply the state as they pass through on their way to markets in the East and the Midwest. Nuclear and hydroelectric sources that the state are rich in, still play a major role in consumption, but are not the most widely used compared to fossil fuels. Through this information, it is clear to see that Tennessee is not efficiently harnessing the energy sources they have within their state and elect to bring in fossil fuels from outside states. We will now look at an in-depth evaluation of the current energy-related environmental problems of non-renewables in Tennessee. Starting out with coal, ash spillage is always a looming threat. In 2008, 525 million gallons of wet coal ash spilled into the nearby Tennessee River and surrounding areas when a retaining wall at a power plant broke. It destroyed homes, affected water quality to many states, and killed much marine life. Additionally, TVA coal-fired plants have been affecting drinking water, whereas coal ash adds to air pollution and greenhouse gas emissions. The picture to the right is one of the aforementioned plants. Fracking is one method to extract natural gas. It contaminates water, leads to methane leakage, and harms local air quality. It can also trigger seismic activity. As for crude oil, it can also be extracted through fracking, which has all the same negative effects I just mentioned. Lastly, nuclear energy poses a major threat with possible fires in spent fuel storage pools and the dangers of improperly storing radioactive waste. Moving on to renewables, I found a report from Oak Ridge National Laboratory discussing hydroelectric power causes negative environmental impacts of blockage of fish migration routes, water level fluctuations, water quality, and harms threatened or endangered species. These negative impacts are also on top of the constant danger of flooding that could harm and relocate whole communities. Solar energy has major land use problems as well as air quality, noise pollution from solar farms, and major water use when used to clean the panels. Recent controversy occurred about a proposed wind farm in Tennessee that was suspended after complaints by locals that it ruins the scenery and hurts wildlife. The project was suspended when local Tennesseans complained about the proposed wind farm's land use, threat to birds and bats, as well as potentially affecting the elderly and autistic children. Continuing with renewables, biomass poses threats of land use, soil disturbance, nutrient depletion, impaired water quality, and oil and air pollutants such as carbon monoxide and hydrogen sulfide. As for the last renewable resource, geothermal, Tennessee does not produce it since the land of the state is not suitable for it, as you can see from the chart on the left. In order to create an accurate energy profile, we need to calculate the projected population and industry growth from 2017 to 2032. The current population of Tennessee is 6,651,194 people, with a projected population of 7,575,882 in 2032. That's nearly a difference of 1 million people. Multiplying the energy consumption per capita value obtained earlier in the presentation, the energy required from the population growth is 3.04 times 10 to the 14th BTU. As for industrial facilities, I've assumed that a proposed trend from 2014 to 2024 I found will continue until 2032. This projected growth rate of 1.2% results in an increase of 2.16 times 10 to the 14th BTU, as you can see from my calculations. Moving on to the last and most important section of this presentation is my proposed energy profile for Tennessee in 2032. I have constructed a pie chart of how I would divide the primary energy sources in Tennessee. The largest chunk of 30% of the future energy demand goes to nuclear energy, followed by coal and natural gas. I do not think we will be marginally phased out of fossil fuels in just 15 years, so I tried to make these numbers better, but realistic. Solar is next, then wind and hydropower both at 10%. Addressing the environmental concerns of my choices, I'm going to discuss each option and explain how and why it can reduce CO2 emissions as well as staunch each energy resource's own concerns. First, for nuclear, I propose that all currently operating and future plants switch to thorium to reduce current environmental concerns. Thorium nuclear power is less harmful to humans because it emits alpha particles, not gamma, produces less radioactive waste, and it basically has no CO2 emissions. As for solar, there is a great potential for it in Tennessee. Since solar can be produced right where the energy is needed, CO2 emissions will go down since the state will not have to import as many fossil fuels. Many say that solar panels are extremely expensive, but the price has been decreasing steadily. Additionally, Tennessee has a sales tax exemption to help alleviate the cost of buying solar panels. I propose that coal consumption is reduced to only what the state can produce. This reduction also cuts down CO2 emissions from transportation of imports. Also, I propose that the state legislation implement a cap-and-trade policy on industry to further reduce emissions. Natural gas should also be reduced by shutting down 2 of the state's plants and implementing cap-and-trade policies. With solar in place, less households will use natural gas for heating and therefore reduce emissions. Crude oil must be nearly cut out of the state's energy profile because it produces so little. As for hydropower, it is a renewable source, but it has many setbacks. I propose current operable dams be reduced by 20%. This means less methane and CO2 emissions. Of the remaining dams, fish passages should be integrated into them so the fish can still travel down water resources. Lastly, wind should be utilized more, but just like solar, prices for it are decreasing as well as wind power produces little CO2. This concludes my presentation. All references used in the video are on the next slide. Thank you so much for your attention.